Okay, so today we're going to work on trying to determine how ionic compounds are created. And if you remember from our previous definition of an ionic compound, the positive charge must equal the negative charge. So what you need to do is go to your periodic table and find the ion for sodium, find its charge for an ion, and you will find that it is a +1. Find the charge for chlorine, you'll find that it is a -1. Then visually, you'd be able to see that the red is for the positive ion and the blue is for the negative ion, and they each have a number of zones for the other one to fit in. So this positive cancels with that negative, giving you a 0 charge for that ionic compound. Then if you do the same thing with the next group, with magnesium and chlorine, find magnesium on your periodic table, you would see that it has a +2, and chlorine, each one has a -1. So visually, magnesium has 2 areas because of its +2 charge, and chlorine has a single one, but you need 2 of them. So if you do that and you need to identify what the compound looks like, when you write the formula, you've got 1 magnesium canceled with 2 chlorine. Here is 1, there's the other, and only 1 magnesium. Moving over to the next example, sodium on the periodic table, +1, oxygen has a -2. Visually now, you'll see that this oxygen ion has 2 points, and you need 2 sodium ions to cancel out each individual point. So this formula is written with 2 sodiums and 1 oxygen. Here, for barium and sulfur, barium on the periodic table has a +2, and sulfur has a -2. So you have 2 zones for barium and 2 zones with sulfur to give you only 1 barium and 1 sulfur to cancel out the charges. If you then have to name these compounds, you have to remember that the anion, the negatively charged particle, changes its ending to IVE. So sodium combines with chlorine to make sodium chloride. Magnesium